Alright, this video is going to talk you through how fuses work and how resistors in general work. So I'm going to create just a circuit here. Doesn't really, I'm just going to start throwing stuff over here. Literally, I'm just going to start cranking this out. Alright, so we're going to start putting some, let's see, let me get some complexity here. I'm going to add just a bulb here. And it doesn't really matter what the resistor is, but I want you to see that these resistors are going to alter the current. And the key to this that I want you paying attention to is that the fuses are going to burn. They're going to blow. It's simply like a safety feature. And once it reaches a certain current level, that if it's too much, then it's actually going to blow the fuse. And it simply just melts the kind of a metallic or a wire filament within here. So if I have a battery, here's my battery, here we go. And notice that one battery connected to one bulb here blew these fuses. So let's take a look at how we can modify this so we can actually get light, but we're not blowing the fuses every time. So watch how this works. Let me replace this fuse. Let me replace this fuse. And I'm going to add a resistor. I'm going to add a 100 ohm resistor here. I'm going to add a 100 ohm resistor here. And let's look what happens. That the resistors are going to make the current manageable so that we get light. So these fuses, these fuses here are simply, they're indicators of current. That this blue fuse right here is only going to allow for 0.15 amps of current to flow along this branch. And this 0.30 current amp fuse, or amp fuse, is only going to allow 0.3 amps of current. So I know that the current is less than 0.3 amps here, and I know that the current here is less than 0.15, and I can actually test that. All right, I can measure it with my multimeter. And it's 0.09 amps here, and it should be the same over here, 0.09 amps. So remember, my voltage here is 10 volts. And if I know the current, right, if I know this current, I would actually also be able to calculate what the resistance of this resistor here is. But notice what happens if I switch out this 100 ohm resistor with a 20 ohm resistor. Could be bad. Boom, we just blew that fuse. So if I put the proper resistor back and I switch out my fuse, you get your light again. So I guess the key to this is paying attention to what resistors are. And resistors help us manage the amount of current flowing through a branch. That you don't want to have too much. Too much current can do damage to electronic devices. And therefore, adding resistors allows you to very precisely calculate how much current is flowing through a particular type of branch. And it's a safety feature. I like the safety feature explanation because as soon as you get too much current, right, watch what happens when I just kind of crank this up. Boom. Something bad could happen, and it did. It blew this fuse, but it didn't blow this fuse. This here still has enough. Remember, the fuse here is 0.3 amps, so the current here must be less than 0.3 amps, and it's 0.17 amps. Notice 0.17 is greater than 0.15 amps, so it blew this particular fuse. So hopefully you realize the takeaway to this when I set up a parallel circuit, that fuses are safety features that blow out after you reach a particular required or some value of current. If it's greater than 0.15, this 0.15 amp fuse is going to blow. And this is a 0.3 amp fuse, and this current right here happens to be less than that. It's 0.17 amps. So this one still works. This light here, this light blew out. Well, this fuse blew out, not the actual bulb, because we exceeded the current that's allowed. And so when I look at this here, there's no measure, and if I replace this fuse, it should blow out again because the current has been exceeded. But if I put this fuse in here, bulb should come on. That this fuse is limiting the current to 0.3, and if it surpasses 0.3, you are going to blow the fuse. And just to end this, I will blow this fuse. Boom, we're getting close, 0.26. Oh, what happens if I twist this up a notch? And boom, we just surpassed the current necessary that the fuse, well, let's just say it melted the metallic strip in here, and it opened up the circuit, and no current flows at all. Hopefully that helped.